Differentiator in today's competitive landscape. Every day, your business pulls in huge quantities of it, from web interactions to inventory counts, diagnostic reports to consumer feedback. And then it sits, separated across systems, unstructured and disjointed. Being able to look out across all that data, connect the dots, and see the bigger picture is key to your company's success and survival. Machine learning gives you this ability. The chance to view your data in a whole new way. Instead of following code and commands, it learns from what you compile to find patterns and insights that not only make you smarter, but can revolutionize how your business runs. At Google, we use machine learning to optimize all our products. From real-time traffic in Maps, spam detection in Gmail, and facial recognition in Photos. And now, we've designed a platform especially for you. Predict when to ramp up production. Know when your customers are ready to upgrade. Diagnose new diseases with speed and accuracy. The more data you bring to it, the more unique insights you're given. The more opportunities you have to redefine how your enterprise runs. This is the future of how machines and people work together to transform how we all do business. The technology is here, and it's waiting for you. Will it make the difference for your enterprise?
Welcome to Cloud on Air, the journey from big data to AI. Thanks to all of you for taking time out of your busy schedule to join us today. I'm Jen Bennett, Technical Director in the Office of the CTO for Google Cloud. In my role, I work with strategic customers as a trusted advisor and as well as a champion and an advocate within the organization for strategic initiatives. We are thrilled to have over 94,000 participants joining us today from over 100 countries. And we have a great lineup of keynote speakers for you today, as well as a number of excellent sessions across 3 tracks: big data, AI, and industry solutions. You're going to hear speakers talking about the importance of data, serverless data analytics, the future of AI, and democratization of machine learning. You're also going to hear about examples of where this technology is being used today to deliver business value. So don't miss the session with General Motors and Marriott, where they talk about their adoption of AI and how it's meeting their business needs. But before we get to that, I want to talk about you. Data and technology are great enablers, but the magic behind the technology is people like you. In a recent PwC CEO annual survey, 77% of CEOs cited that the biggest concern and the biggest threat to their business is availability of skills. Thinking skills, problem solving, adaptability, creativity, and innovation. So what's going to differentiate a business in this ever-changing landscape? It's going to be the people. People who can understand the technology and the possibilities to leverage that technology to solve business problems. This is what's really important, and this is what will differentiate the business. No matter where you are in the organization, no matter what function or level, your ability to leverage technology to solve your business problems. So, people are the catalyst. You're the catalyst within the organization. You can take the technology and start to chip away at some of those business problems. It's people connecting technology to the business problems, driving some of the process and transformation within your organization. Leveraging technology as an enabler, but using your creativity and innovation to think about problems in a new way, to think about data in a new way. This is what those CEOs were talking about. Technology is changing faster now than ever before, and with that, new ways of approaching problems with new technology. Across the sessions today, you're going to hear about people doing just that, thinking about problems in a new way, using technology to deliver significant results. So be inspired by what's possible. And as you listen to our experts talk about big data, machine learning, AI, and industry solutions, think about a problem or an opportunity in your organization where you can be the catalyst to leverage technology to solve your business needs and hopefully deliver value to your customers. So once again, thanks for joining today. As a reminder, we have a number of Google Cloud product specialists on hand to answer your questions. So use the little Q icon to submit your questions throughout the session today. But I'm ready to get started. So with that, I'd like to invite Rajen Sheth, Senior Director of Product Management for Cloud AI, to talk about the future of data and AI. Rajen?
Thank you. Thank you, everyone, for joining. We really appreciate your time today. And I want to talk to you a little bit about what is AI, how can it be useful for you, and what we're doing to help bring that technology to you. So let's start with the question of what is AI. It's interesting because AI is actually not a new concept. This is something that first made its way out there in the 1950s and has progressed really ever since then into kind of newer and newer technologies. But what we've really seen within the past few years is really a renaissance in AI. We've been able to actually really make use of the technology to really bring useful applications to people. And what's really made that possible is large computing resources and large amounts of data. And that really kind of changes the paradigm and changes how we think about how to program computers. If you think about how do we program computers, before, what we would do is we would give the computer all of the rules that it needed to be able to do what it needed to do, and then we would run a program. And AI twists that on its head. What it actually does is it learns from data. And in fact, it gets it wrong for a while, but then over time, as it sees more and more and more data, it'll get it right and actually be able to predict and look at things that we may not have been able to look at before. It reminds me kind of where we are of where the internet was in 1994. And think back to kind of the first time you saw a web browser. For me, when I first saw that, you could start to see the promise of the internet and the kinds of things that it could do for me as an average person. For me, it was sports scores. All of a sudden, I could get sports scores right away. And then you could start to see things like being able to get news right away, being able to purchase things online. You could start to see that the internet was going to be a big thing. We're really in that moment for AI. We're starting to see amazing applications that are going to make this really relevant for everybody out there. And what I want to tell you about is how this is going to be relevant for you. So one common question that we get from a lot of our customers is, I know I should be using AI, but why should I be using AI? What kinds of things will it be able to do for me? So a few of the things where we're starting to see AI and machine learning really start to apply is kind of in these four areas. Personalized customer interactions. How can we make it such that every customer that walks into a store or walks into your office feels like they're having a personal interaction with you and you know them extremely well? This could be everything from, for example, being able to infinitely scale your customer service resources, or making it such that when somebody comes to an e-commerce site, they're able to get solid recommendations of what to do next. Things like that that are kind of taking that step to really knowing the person. But then you could start to take it even further than that. An example of this is Ocado, which is a grocer, an online grocery in the UK. They're using some of our technology to be able to take a look at incoming email and figure out if a customer is angry or happy. And if it's an angry email, they're able to then escalate it and make sure that they get service to the customer very quickly. Efficiency and agility is another big area. What we're starting to see with this is that customers are looking at this and really figuring out how to make their infrastructure more efficient. We use this within our own data centers, and we've used machine learning to save 40% on our cooling costs just by optimizing how we use resources. And we're seeing that in areas like oil and gas, for example, or in things like industry controls. Being able to optimize how you use your equipment, and also be able to do things like predictive maintenance, for example, too. A third area is spotting patterns. How do we find patterns out there that'll help us actually figure out what to do? A great example of this is Rolls-Royce Marines using our technology to be able to spot obstacles in a sea route and be able to navigate as a result of that. And this is just one example. There are many places where artificial intelligence can spot patterns where we may not even see the patterns. And then the last thing is really adding structure to your data. Over 90% of the data that's out there within the typical enterprise is unstructured data. And so how are you going to find information there, and how are you going to figure out what type of information is out there? This is another place where AI and machine learning really resonate. Box is using some of our technology, for example, to be able to let a customer put their images into our algorithms and be able to categorize those images and find information and metadata about those images. And that makes it so that people can actually have a better understanding of what images they have. So the second big question that comes up is, okay, I know about machine learning and I know what I want to do, but why should I use Google? And I'm going to take you through kind of our journey here. So first, let me describe to you a little bit about what we mean by AI and machine learning. AI is really kind of this concept of how do you actually roughly mimic the kinds of operations that we have in the human brain to be able to perform actions. And machine learning is one of the most promising techniques for doing that. And the way we do it is by actually having what is known as a neural network, where we mimic the neurons that are there in the brain, and then we have layers of them. So the output of one set of neurons fits into the next one, which fits into the next one, and it arrives at a decision over a set of layers. And so an example of this is this picture. So if you look at this picture, any of us that look at this will recognize that this is a dog. But if you think about it, it's actually kind of tough to figure out, is this a dog or is this something else? But we know, we've seen dogs so often that we know that it's a dog. So when this goes through the network, what we're doing with the computer is that we're feeding it. It tries to use a set of algorithms to categorize it, and then it comes out with whether or not this is a dog or a cat. And a lot of times it's going to get it wrong initially. But what we do is we learn from that. And we feed it back in to be able to say, no, this was actually not a cat, this was a dog. Or we feed in other images that we know are images of a dog. And that makes the network smarter and smarter and smarter to the point where it can very quickly recognize a dog. So imagine doing this over millions of images. At that point, you get to the point where it is very clear how to spot a dog from a cat. And so then you can get to very, very high accuracy. And this is just one example of this. And the amazing thing here is the computer was not trained at the beginning or didn't know how to think about a dog versus a cat. But now it actually is able to figure that out. So to us at Google, this really is a paradigm shift. This is more than just a tool. This is actually a new way to think about computer software. And we've really adopted it to the point where Google really is an AI company. And so if you think about our journey, if you look back, say, 3 years ago, we weren't really using much in terms of AI. But now what we're doing is you can see AI being used across many, many projects throughout the company. And so you can see on this graph, just over the course of those 3 years, we've gone from just a few hundred projects at Google starting to use deep learning now to almost 7,500 projects within Google that are using deep learning. And in many of the products that you and I recognize, things like Android, things like Gmail, things like YouTube, we're using it in more and more ways to really help our users do what they need to do. And what we want to do now is make it such that it's possible for you to use the same technology that we've built to solve your own problems. And so the goal of our team here with Cloud AI is to make AI easy, fast, and useful for enterprises and developers. And let me dig into that a little bit. Easy, meaning that we want to make it so that anybody that knows how to use code can use AI. And so all of your developers out there should be able to use AI. Fast, we want to make Google the fastest place to run AI. Computing power is paramount here, and we want to make it so that you know when you put your workloads on Google and your AI workloads on Google, you're putting it in the best place. And useful, we want to solve real business problems with you, things that are going to actually affect your bottom line, and make it so that this is more than just something that's interesting, make it something that is actually business critical. And so the advantages that we have in AI are things that we're now passing on to all of our users. Our scale, we can bring to you thousands upon thousands of servers to be able to process these. And as we talked about at the beginning, really the reason AI has been so useful now is because of the amazing computing power that's now available in the cloud. The second thing is speed. We've really redesigned our infrastructure over the past few years to optimize it for machine learning. And what we're now doing is providing that same infrastructure to you as well, too, so that you have the most optimized infrastructure. The third part is the technology. We've now brought to bear all of the technology that we have internally around AI and are providing it to our customers. This includes TensorFlow, which is our deep learning framework that I'll talk a little bit about that we've now open sourced, as well as AI building blocks. And what I mean by this is we've taken a lot of the best AI models that we've built internally and we now provide them to you as APIs. And the last part is ease. So we provide a set of developer tools that make this easy for you. And then we also have programs like the Advanced Solutions Lab, which will make it so that we can work with you more closely so that you can learn from the experts at Google on AI. So the technology stack looks really like this, kind of from the bottom to the top. And it starts with our cloud and the scalability that we have with our cloud to be able to scale over thousands of servers. And then all goes up to how we design our servers. And so what we've done is from the silicon up, we've designed our servers to be optimized for AI. And we do this with a concept called the Tensor Processing Unit, the TPU. And we're now providing that with Google Cloud. And I'll talk a little bit about that in just a minute. But this gives you an amazing advantage in terms of performance. On top of that, we have TensorFlow, and that is really our framework by which we implement deep learning and implement a lot of the algorithms that we have. What we've done with cloud is that we've given our users a set of development tools with Cloud ML Engine and Data Lab, which make it so that you can start to develop your algorithms, and you can start to not only do that, but bring in data from other areas and make your algorithms better and better and better. We have the AI building blocks that I mentioned, which are APIs to some of our best models and making it so that you're able to utilize a lot of the things that we've spent years developing. And then lastly, solutions and customization to make this really optimized towards your particular business use case. And so we're now starting to get into things like this, and I'll talk about some of the things that we're doing here. In addition to the technology, we have the community around it to make it so that this can become relevant to you, and you have people that can help you along the way in the journey. We acquired a company called Kaggle recently, and Kaggle has 1.2 million data scientists out there that are able to work with you on interesting AI problems and interesting machine learning. In addition to that, we have a community of partners that are able to work with customers to be able to implement this as well too, or have implemented this into their own applications as well. And by using this community, you can more easily bring a lot of these technologies to your set of users. So we think of AI really in three areas: the infrastructure, these building blocks, and solutions. And I'm going to talk through each one of these. So with infrastructure, it starts with Google Cloud. It really starts with the storage of the data and your ability to get to that data. And we're going to talk a lot more about our data tools that will allow you to bring in data from many different places and analyze that data, and then also bring it into machine learning. It goes to the compute, being able to use thousands of cores, GPUs, TPUs to be able to do these jobs. It then goes to the models, being able to actually build these models on top that can actually scale. And then once you have those models, being able to put it into a production workload and serve a high throughput to be able to put this as part of your mission critical applications. At the silicon, we've implemented what we call the cloud TPU, as I was mentioning before, and we've custom designed the silicon to be able to be efficient for TensorFlow in particular. And we get an amazing 180 teraflops of performance out of these chips to be able to really exceed what's available out there right now in terms of speed. We provide Cloud ML Engine on top of that. And what this does is a way by which you can take your model, be able to upload it to Google Cloud, and have it be able to go through the various stages of life cycle and then scale. So this allows you to do things like training and then productionizing and online prediction with your models. But then it also allows you to do things like, for example, do tuning of your model, things like hyperparameter parameter tuning, and then figure out what kinds of these accelerators do you want to use. When do you want to use CPUs versus GPUs versus TPUs? We provide a visualization environment on top of that as well, too, so that you're able to interact with that and be able to try it and test it and make it better and better and better through a tool. TensorFlow is what this is all based on, and this is now the #1 repository for machine learning in GitHub. And this has become more and more and more popular over the course of the last couple of years that we've had this out there. We're going to continue to add to this as we develop great things here within Google, so that we can share that with you. And the interesting thing about TensorFlow, because it is open source, you have portability of these models. You don't just have to run that on Google's cloud. You can take this and run them in a variety of different places. You can now take it and run it on devices like a cell phone. You can now also take it and run it on-premise as well, too. And so it gives you that ability to really move around and be able to use your model where it's most needed. So the next layer here are the AI building blocks, those APIs that we have to great applications that we provide. What we've really done here is we take a lot of the fully trained machine learning models that we have, some of the things that you're familiar with a lot of our consumer applications, and we provide APIs such that you can use it. And we have a set that's already out there, and you're going to continue to see us add to this and bring, as we have more great technology, bring that to you. So a few of the examples of what we have here. Image recognition. Think about what you see in Google Photos. We can now take in an image and tell you metadata about that image. What kinds of objects are in that image? If it's a picture of a piece of text, we can actually tell you what that text is and actually convert it to text. If it's a picture of a face, we can tell you if that person is happy or sad, or tell you the emotion of that person as well, too. So things like that can really kind of give you a handle of the images that you have. We've now taken this to video, and you could do similar types of object detection, but in addition to that, you can do things like scene transitions and understand kind of where there are transitions in scenes within a video, and various other things as well, like, for example, explicit content detection as well. Many people know Google's strength in things like machine translation, and we are now able to actually bring that out to our customers. But then also things like natural language processing, where you're able to put in a piece of text. We're able to detect the entities within that text and be able to give you an idea of the structure of the text, what that text is about, and how you can use that. And of course, Google is known for our speech recognition with things like Google Assistant, and that's now available as an API as well, too. Now we're actually going even further and starting to customize this for particular solutions. And recently we released what we call Dialogflow Enterprise, which is a way by which you can do things like build chatbots and build conversations so that you can be able to interact with your customers, or have something that interacts with your customers to be able to diagnose a customer's problem before it comes to, for example, a call center. And so things like that really let you scale. So to wrap it up, really we want you to be part of this vision, to be able to bring this technology to you. And we already have 10,000 plus customers that are working with us and a variety of partners, and we're looking forward to working with you to make this a reality. So with that, I'd like to introduce William Vambenepe, who leads a lot of our data products and can tell you about how you can bring your data in to these algorithms.
Thank you, Rajen.
Thank you.
Thank you. Thank you all for joining us. I'm William Vambenepe, and I lead the product management team for big data services on Google Cloud Platform. And as Rajen was describing, AI is really about data. And that's also what analytics is about. And so the two are really complementary and work on the same business data. And so to really benefit from AI, you also have to have the kind of control on your data that analytics provides, which means that you need to be good at analytics to be good at AI. And while that may sound like a somewhat negative statement, that's actually a positive, that's a chance. Because what it means is that the work that you put into analytics is something that directly can be leveraged into your adoption of AI. And so it's really not two parallel tracks, it's one continuous set of tools that allow you to derive value from data. And so let's talk a little bit about analytics and what it takes to get access to your data and what value you can get from it. And quite often, it seems like the equation is reversed, where it's not your analytics system working for you, it's really you working for them. And that's just wrong. And that's just what has been stopping a lot of companies from using analytics productively, and what has led to numbers such as those on the slide here that show that a very small portion of all the data, most of it is unstructured, as Rajen said, a very small portion of it is actually used productively. And even within structured data, we're quite far from being able to productively use all the structured data that is relevant and available. And so that's something that we've worked hard to change, initially just for Google own use, and now something that we're bringing to all users on Google Cloud Platform. And some of the main ways in which we've worked to provide that, one is by driving from the start very strongly on a serverless model. Even before the term serverless was used in that context, we've driven really hard to make all our analytics products available in that way, which I'll describe in more details. We're also standardizing on streaming by default, as opposed to a batch-orienting model, which obviously has its place, and we'll talk more about how we went about that. We've also incorporated the best of open source and brought Spark and Hadoop and other open source tools, some of which that Google contributed, like TensorFlow, and others from the community, make sure that they run really well on Google Cloud Platform, with the goal, once you have all that data, in addition to analytics system, to be able to use that with the AI systems that Rajen described. So let's go back to serverless. What is serverless? In this context, serverless, the term now is used really to represent the fact that a lot of the infrastructure management and setup that you normally have to do on a big data system can be taken away and handled by the cloud provider. Now, there's no magic. There's still physical servers and network and cooling and software. Those things don't go away. What's different is that as a user, they're not your concern. And that the cloud provider, Google in this case, is the one doing that, which is great because that's something that Google is really good at. That's something we've been doing for a really, really long time. And so it works very well in terms of user productivity to be able to offload that work and not have to worry about scaling and deployment and things like that. There's many parts to serverless model. One that's pretty clear is something like auto-scaling. And so, if you have a data processing pipeline, whether batch or stream, and we'll talk about that in a little bit, the throughput of data going through the pipeline is not the same throughout the life of the pipeline, because a batch pipeline has different stages, or a streaming pipeline reacts to a varying stream of events coming in. And so, if you provision for peak, then you you don't really know what the peak is going to be, so you have to over-provision if you don't want to ever run out of capacity. And then you end up with idle resources. And so in a serverless model, one of the things that PubSub, Dataflow, BigQuery, all our serverless products do is auto-scale the workers such that at any point in time, you have the right amount of workers and no more than the right amount of workers. And what we mean by that is not auto-scaling within a cluster. It's global auto-scaling. Now, resources just go away from your perspective when you don't need them. And really allows those systems to be not just more reliable and faster, but solid and able to respond to your user demand very reliably. And so auto-scaling is just one aspect of serverless. There are many others, and you can see in the pie chart here on the left, some of the things that typically you as the user are responsible for in an on-prem big data system, or even a cloud system, which is not serverless. The hardware deployment might go away in cloud, but everything else in a traditional VM-based cloud system is the same, where you have to deal with deployment and optimization and performance tuning and just managing the infrastructure. In the serverless model, really all of that goes away. The only thing that's left is the part where you bring your expertise, your domain knowledge, your understanding of the data to get value from it without worrying about how the tool works and how to optimize your consumption and your availability. And so to hear that in practice, we can see a video where Spotify, one of our users, described how serverless has changed the way they process data and help them deliver better customer service.
The mission of Spotify is really about being a great musical companion and making it more personal. It's not going to be the streaming music experience or the online music experience. It's going to be your music experience.
We create the tools for people to actually swim in that sea of music data and find the information that really corresponds to why they're there.
Quite a while ago, we've made a decision to focus on data.
Depending on the complexity of the query, it could take a whole day. Sometimes it would have to run overnight.
And being able to store that and process that has been a very big challenge. Moving to Google's cloud platform enabled us to take use of the skill that Google can provide.
The reality is it's quite hard to build great data centers, and we saw an opportunity to spend our focus elsewhere. And that was really the driver into Google's cloud platform.
With Google Cloud Tools, we can rerun the same query, and it might take a few seconds, minutes.
The less time that we can spend solving problems that are already solved, like scaling our Hadoop cluster when Google has already figured out how to scale it for us, the more time and energy we can spend on turning our data into value. And that's really a game changer for us. When you're talking about a technology like BigQuery, when you're talking about data flow, you will feel the Spotify product evolve, making the user experience great.
Once you break down the data, you realize that there are nuances. It's not a straightforward path. It's a mosaic rich beyond the most popular artists. It's a lot more than that. Music can transcend boundaries of language, culture. If it moves you, then it's there, and it's there forever.
All right, so this was a very, very rewarding story for people in our team who work on those services and see them being used in practice. One aspect here that was touched a little bit as well is the move to stream pricing. Applications like Spotify are all about pricing events as they happen. And so a big part of that is using stream processing, in many cases a replacement for batch processing, which has been the de facto standard in the industry for most large data processing, to the point where it became almost intuitive to many people. And that's really something we have to unlearn, because in the real world, things don't happen in batch. Things happen continuously. And it's actually easier and much more effective to process things in that way and handle events directly as they arrive. And so we've built an entire portfolio of products throughout the lifecycle of data, from the point of ingestion to support that, and to support use cases such as shopping and IoT and transaction, security, alerting. There's plenty of use cases across industries where time is money, literally, or even when it's actually not, fundamentally something that has to happen right away. There really is no need to add the additional complexity of a batch pipeline, and we can just handle the events as they arrive and just provide quicker insight and not reserving stream processing to the most advanced use cases. It's now something that's available for everything, with services that cover the full lifecycle, from the point of ingestion, where something like Cloud PubSub, serverless event delivery system, globally scalable, that can receive all the events, deliver them, to something like Dataflow, which is our serverless batch and stream pricing engine, allows the pipeline that you've written. Again, you've just written the logic of the pipeline. You haven't deployed anything. We'll run those in streaming mode into sources like BigQuery and like the ML systems that are available on the platform to do real-time prediction on this data. And so from start to finish, you can use fully managed serverless systems for stream analytics towards ML. And the architecture looks a bit like this, where obviously in many cases batch doesn't go away completely. It's a transition that takes time, and there are some data sources that fundamentally are batch oriented. And so you want to incorporate them, you want to support stream processing. What Dataflow gives you is, by offering a programming model that unifies batch and stream, allows you to write a pipeline once and have that pipeline handle both batch and stream. And as sources, typically batch sources become streaming, the same pipeline can keep handling them and then deliver them to downstream services for analytics with BigQuery and visualization and data science and machine learning, all in one well-integrated, easy-to-use platform. Another aspect of the platform is the fact that it brings the best of open source to Google Cloud, and you don't have to choose between fully managed cloud-native services like PubSub, like Dataflow, like BigQuery, or open source tools like Hadoop and Spark. You can mix and match the two, and we've made that possible by making Hadoop really easy to run on the platform, by making it really, really fast. We start a cluster from 0 to ready in under 90 seconds. You pay for it by the second, so it's very easy to use, very dynamic, and you can use it on the same data that BigQuery and Dataflow use. And so you can really mix and match the right tool for the right use case, all on the same platform. And then finally, one of the other key pieces of the big data platform on Google Cloud is BigQuery, our cloud data warehouse. And a way to think about that is to follow the evolution of data warehousing across the years. From the early starting point, on-prem data warehouses, move towards BI. Now kind of cloud data warehouses, where BigQuery is the shining example of that in terms of being serverless, having storage and pricing decoupled from the very start, very flexible model for cloud data processing, and the evolution towards more and more machine learning and AI, and BigQuery playing the role of being the data warehouse, which, thanks to all the work that Rajen described that Google is doing on machine learning, will give you that access on your data in addition to the traditional SQL-based access. And so, speaking of BigQuery, I would like to invite on stage Jordan Tigani, who is a tech lead on BigQuery itself.
Howdy.
Thank you, Jordan. I want to ask you a few questions about BigQuery, especially in the context of ML. And let's start with predictive analytics. Like, what does it mean? And in the BigQuery context, what are the use cases for predictive analytics that you see?
Sure. So anybody who's doing data warehousing can really take advantage of predictive analytics. It really lets you kind of take your analytics to the next level. You go from just being able to answer questions about the data that you know you have to being able to answer questions based on deep patterns within the data, or even data that you don't have. For example, you might not know what language your customers speak, and so you can apply machine learning algorithm to the Google Cloud Machine Learning API to determine which language they're speaking. Another big example that we see a lot of times with BigQuery customers is fraud detection. So they use known examples of fraud to build a model of what fraudulent activity looks like, and then they use BigQuery to analyze their logs and look for things that match that pattern. BigQuery is also a great place to do that because BigQuery allows you to combine data from a lot of different places, and often with fraud detection, you want to combine as many sources as signals as you have.
And so on that topic, technically, can you say more about what makes BigQuery so well suited for predictive analytics?
Sure. You have to look across the sort of the life cycle of how you do your predictive analytics. So first of all, you're going to need a place to store your data. And BigQuery is a great place to store predictive analytics data because generally that data is structured. And BigQuery is a great place for structured data. It allows you to manage your data life cycle, allows you to share your data with whomever you want. And then once the data is in, you need to understand it. I mean, that's a big part of any kind of prediction process is developing a feel for your data. And BigQuery has strong connections to a bunch of BI and visualization tools, our own Data Studio, but also Tableau and Looker are great ways to get a feel for your data. And then you're going to want to transform your data. So you may have to clean up the data. You may want to look at outliers. You may want to apply some statistical resampling to your data before you're ready to actually do the prediction. And then finally, BigQuery has excellent integration with tools that data scientists are using already, such as R and Pandas, and there's Google Cloud Data Lab and TensorFlow as well.
Okay. What about streaming? I know just earlier I was describing the move to streaming analytics. How does Google Cloud support that in the case of predictive analytics?
Sure. So, as you mentioned, that streaming is a use case that Google Cloud is really focusing on, and I think people want to reduce the time to their time to insight. So instead of just being okay with daily reports or even hourly reports, people want to know what's happening up to the minute or up to the second. And so there's an architecture of a bunch of Google Cloud products together that can make this work extremely well. So you may have your events being generated either from sensors in a factory or a pixel beacon on your web page, or perhaps transactions from your stores around the world. You send those to Google Cloud PubSub, which gives you reliable global message transport. You process those with Google Cloud Dataflow, which allows you to kind of transform the data, and then you can send that to Cloud Machine Learning Engine to maybe apply a demographic model or one of the Google Cloud APIs, machine learning APIs, to do language detection or sentiment detection. Then finally, you can stream it into BigQuery, which the whole time taken by this process is generally less than a second. So the queries that you run then can combine kind of predictive analytics and prediction, but they're really up to the second.
Okay. And you talked about those streaming sources, from IoT, from applications streaming into BigQuery. What about application data? How can people bring their application data in their enterprise application to BigQuery?
Sure. So that depends on where your data comes from. Getting data into BigQuery, as we know, is super important, because if you can't get your data in, then you can't actually analyze it. So one big class of data is the streaming data. We believe that all large data sets are generated over time, so we want to make streaming work as well as possible. And BigQuery streaming and instant availability is a large class of data. There's also data that Google already has. So this could be AdWords data or DoubleClick for publishers, Google Analytics data. And Google Transfer Service allows you to automate ingestion of this data automatically into BigQuery. You may also have data sets on-prem, or data sitting around that you want to get into BigQuery, but you don't quite know how to do it. And data prep is a tool that we have that allow you to do schema transformations and to generate a pipeline that will help you move that data into BigQuery. And there's a final category, and that might be data that could be in an enterprise app or a SaaS application, and it's more tricky to move into BigQuery. And so we've got a number of integration partners like Informatica and Talend that will help you get that data in.
Okay. And so speaking of how BigQuery, in addition to providing analytics and dashboard and traditional analytics, also support the move to ML, how can BigQuery be used to prepare data for model development?
So pre-processing is A, one of the hardest, and B, one of the least satisfying things for data scientists. I think I saw somewhere that 3/4 of data scientists said that data pre-processing was their least favorite part of their job. BigQuery makes it really easy. You just you write a SQL statement and you hit query. There's a kind of a traditional way of doing ETL, so extract, transform, and load. And the last part is sort of in your database. BigQuery makes ELT possible. So you get the data in, and then you do whatever your transformations you need in BigQuery just in SQL. It should be really easy, and if you can't figure out how to do it in SQL, we also have user-defined functions that will help you kind of do things that may be more complex. And finally, BigQuery makes it easy to share both queries and data sets. So once you figure out the transformation that works, you can share it with your coworkers or colleagues, and so you can kind of productionize the best practices.
All right. Thank you very much, Jordan. We're going to take a very quick break, and we'll be back for a panel. Thank you.
You're watching Cloud on Air, the journey from big data to AI. I have with me my colleagues, many of the keynote speakers that just talked about how big data and AI are impacting the future. And we're going to answer some of your questions. So once again, I'm Jen Bennett, Technical Director in the Office of the CTO. I have Rajen, the Senior Director of Product Management for Google Cloud AI. I have William, the Group Product Manager for Big Data. And again, Jordan, the Tech Lead for BigQuery. So thanks for joining me. We're going to start with the first question. What's the difference between AI, machine learning, data mining, and big data?
So really the difference is starting kind of with AI and machine learning, because those are often used together in many contexts. Think of AI as really the field. It's kind of the concept of artificial intelligence, and machine learning is a tool for that. So think of it almost like how you would think of physics as a field of science and calculus as a tool that you use with physics. And then big data and data mining are how do you actually look at a large amount of data, and then can you bring that data into both ways that you analyze, but then also into machine learning.
Right. Next question. So William, you talked about Google Cloud's serverless data analytics solutions. Can you please explain what serverless means and how it can be used to help an enterprise?
Sure, happy to do that. And actually, serverless, I talked about it earlier in the negative sense, what it's not, what you don't have to do. But maybe the better way to look at it is the positive. What does serverless mean in practice? What it means is that what you can do with it is you can have an idea on your drive to work in the morning, and then by the time you get there, just try something out. You don't have to set up a system and decide how many machines you need. You just write a query. If it's if it's an idea that can be expressed in SQL, you just write a pipeline, you just run it. And in seconds or minutes or hours, depending on the mental complexity of the task, you've tried something out, you've proven it, maybe it's not working, and then you've only wasted 2 hours, not 3 weeks. Or maybe it's working, and then you have something that's ready to productize there and then because it's built on production-ready system. And so really, that's what serverless is. It's empowering individuals and teams to just try things, just make it happen, and progress and iterate much, much faster.
Yeah, I think this whole idea of democratization of data and what I talked about at the beginning about people being empowered to solve problems, I think this is a great use case of that. Next question. So AI is everywhere. Is AI technology becoming more efficient and useful? Or are we at a pivotal stage where humans are evolving to trust machines? I think this is a good one for you, Rajen.
Yeah, it's a very good question. I think it's a little bit of both. I think that we're just starting to see how AI can be useful. It's that browser moment that I talked about in my talk, where we're starting to see that, and you can start to see how this can impact your everyday life or your business. And I think this is going to be one of these things that's going to be an amazing tool for people to be able to use to solve things that they weren't able to solve before.
Yeah, I completely agree. We hear this question a lot, as it comes up in industry. Yeah. How is AI going to be replacing humans and all these sort of things? So yeah, I think it's a popular topic.
It's true, and I think that really, if you look at it, where it's going to be most useful is where it can help people and help augment people's capabilities to make them be more effective.
Yeah, it's great. And this next question came from a computer science student. What aspects of big data and AI areas can we learn at this event? Well, hopefully by now, those of you who have joined have seen the schedule and all the detailed abstracts. But just as a highlight, as we mentioned, we have three tracks: big data, AI, and industry solutions. So, within the big data section, we talk about data warehousing and serverless infrastructure. We talk about simplifying ETL processing and streaming analytics, so some of the topics that you talked about as well, William. We also have areas such as IoT and how that can be used in the data, and predictive analytics. We also talk about running efficiently processing Hadoop and Apache Spark jobs. So a lot of good stuff in the big data space, and I think in the AI space, we really want to get people started. And so everything from leveraging our pre-trained models with APIs to tools to build your own custom models, as well as some of the infrastructure that powers it on Google Cloud. And then, of course, in the industry section, you're going to see how this technology is being leveraged to really transform some industries, such as the finance industry and healthcare, media, retail, manufacturing, and even marketing analytics. So just a few areas, but check out the schedule for more information. Next question. So I think this one is probably for Jordan. How is Google BigQuery different from other data warehousing solutions?
I think the primary thing is BigQuery is the term we've been throwing around a lot today, serverless. I think when we were designing BigQuery, serverless wasn't a term, but we just wanted to make it as easy as possible to remove all the barriers for people to use it. So you don't need to create indices, you don't need a DBA, there's no operations, you don't need to scale up or scale down. You just load your data and run your queries. We also have seamless scaling. So I mean, we only charge you when you're actually running queries. But if you need more capacity, you just pay and we'll give you more capacity. And then finally, there's the ease of sharing, and the other thing when we were designing BigQuery is we thought, well, what if all the world's data was in one database, so it's all joinable? And of course, we need to make it secure, and so that data doesn't go where it shouldn't go. But if you need to share data with a colleague, like that should be super easy, and that works really well in BigQuery.
Yeah, so with a colleague or even people inside the organization, you control who you share with, but it could be across companies as well. That's really powerful.
Yeah, great. How can AI be used? Sorry, I'm going to move on to this question. How can AI be used in an IT infrastructure management and operations? This is coming from a system engineer.
So I can take that one.
Great.
To some extent, that question is becoming less important and more important. What I mean by that is, in many cases, the kind of task that people are responsible for doing on-prem that they might look at AI to automate, those tasks themselves can go away. And that's what serverless does. I talked about auto-scaling earlier in the keynote, and how Google takes care of that automatically. That means that you don't even have to find better ways to do it. You just don't have to do it at all. Now, there's still plenty of systems where you want to keep control on the feedback loop and the behavior of your application, and that could be because you want to drive that based on business data, or an aspect that only you, as the application owner, understand. And in that context, it's really easy to take any kind of signal produced by your application, logs, metrics, external signal, have them themselves go into the data processing pipeline, typically ingested by PubSub, processed in Dataflow, going into BigQuery, and then at any stage of the way, in Dataflow directly in streaming mode, invoke a model that you've trained in Cloud ML Engine, and just be able to make predictions on the fly and make decisions on what to do with your infrastructure, with your application, or do that in BigQuery, as we've described, when data lands there. So you really have access to AI at any point of the process to drive a closed loop between your application and the signal it produces.
Yeah, really powerful. The next question we have here is from a chief operating officer. Beware. How can small and medium enterprises take advantage of big data and AI with limited budget and resources? Great question.
It's a very good question. I think this is where something that we're really striving for is to figure out, how do we make AI available to everyone? And this is where, for example, a lot of the building blocks I talked about really come in play. We've spent years building these models that are really optimized to specific purposes. And so you don't have to spend those years. You're able to actually leverage a lot of the work that we do. But even in a small business context, you can start to build your own models and build things that are particularly custom for you, and are able to use our resources to be able to scale them.
Yeah, I think really important.
And I think just one other thing is around big data and small organizations is that a lot more small and medium organizations have big data than perhaps we expect. Like, people run into scaling issues all the time, and I think Google's cloud is really sort of scale agnostic. So as your data size start to scale, prices should just scale linearly, and things should just continue to work.
Yeah, I think that's important. Even the enterprise itself, people don't know when they start how much they're going to need, and so typically they have that choice. Do I invest ahead of time? So if I'm successful, I'm not going to get stuck, or do I optimize for velocity and then figure it out later? And then if things work out well, then you have this panic and you spend 2 months re-architecting. And so, as Jordan describes, you don't have to make that choice. You don't have to take that risk. Just use the tool, and you know that it will be able to grow with you.
Great. Next question. As an experienced developer, but new to ML and AI, where can I get started?
Yeah, and this is a question we hear a lot, because if you really look at it, there are only about tens of thousands of people that really understand deep learning, maybe hundreds of thousands of data scientists, but there are about 18 million plus developers that are out there. And really what we're trying to do is teach the world how to do this. And so we provide a lot of resources online to help teach people about machine learning, how they can start to how they can start to use it. And there are a lot of other great resources, things like college courses, for example, that are available. And in addition to that, you have our APIs. So if you're a developer, you can just start to use those and be able to integrate those without having to know about machine learning in depth.
Great. Yeah, sort of like a try and learn, right?
Exactly.
Yeah, great. You talked about streaming data analytics with cloud data flow. Can you please help us understand how cloud data flow scales with ever-growing streaming data volume?
Sure, I can talk about that. I mean, it goes back to data and algorithms. I know that's how the decisions get made. So in the case of streaming a data flow pipeline, most of the data comes from either the system, so the workers, the controller that distributes works with the workers and the signal it gets back from the workers, as well as data that comes from upstream sources, so things like Cloud PubSub, which provide metrics around the backlog and the throughput. And so the auto-scaling system looks at all this data globally, uses machine learning to the earlier question about how to use machine learning for IT management. That's a perfect example. I know machine learning and heuristics that we have over 15 years of really running systems of that kind and make those decisions because we've moved way past kind of the naive approach to auto-scaling when you just have one metric, you hit the threshold, oh, I'm going to scale up. And those things really can very easily go into a really bad loop. Now we have much more sophisticated models to scale aggressively when it makes sense, but also to not scale for no reason when it doesn't make sense.
Probably another great example of why you want to rely on people's experience to build out this infrastructure to help you.
It sounds easy, right? Like, my VMs are busy, just throw more VMs. Like that very, very rarely is a good algorithm for auto-scaling.
Yeah, absolutely. All right, great. Next question. Data warehouse stores valuable enterprise data, of course. How do you manage security in Google BigQuery?
So for many of our customers, security is the most important thing, like ahead of performance, ahead of even getting the right answers. They want to make sure that their data stays secure. So all BigQuery data is encrypted, encrypted at rest. It's encrypted on the wire as we're moving it around. We also just launched customer managed encryption keys. So users can manage their own encryption keys, and you're not using our default encryption keys. Sometimes people want to know that their data is not going to get out of Google or get out of their organization. They feel like moving it to the cloud is a little bit of a loss of control. So we're working on exfiltration controls, exfiltration protections, network lockdown controls to prevent unauthorized moving of your data. And then we also have industry standard IAM-based data sharing and access control of your data.
Great. What should my team look like to build and implement an AI strategy for my business?
Well, I think there are different parts of this. There is the data itself, and so you need to take a look at kind of what is the data that you have, and do you have the people there that are going to be able to analyze and utilize the data in the right way. A lot of actually building AI is around taking the data and getting into the right format. There's the concept of machine learning and having people that understand these algorithms, but then there are also the systems expertise that's needed as well to be able to kind of figure out how to turn that into reality. Now that is part of what we're now trying to provide with a lot of what we have here. So you don't have to think of all of those aspects. With things like what we provide with BigQuery, we make it easy to bring your data on board. With things like what we have with Cloud ML Engine, we're able to let you put an algorithm or model there and be able to scale it, so you don't have to think about many of these aspects.
Great. Yeah, no, that's fantastic. Well, unfortunately, I think we're just about out of time. I really wanted to thank my panelists for joining. I think there's a lot of great, useful information that you guys have shared. So thank you. And thank everyone for joining us today. And stay tuned because there's plenty of sessions, some really great information for you to take with you. I want to remind you that we do have Google Cloud Product Specialists on hand to answer your questions. So again, use that Q icon to ask your questions. As well, we have that feedback icon. We love feedback, so please use that. It'll open a form which you can fill out and share your thoughts about the session throughout the day with us so that we can really make this better for you in the future. So again, thanks for watching and stay tuned, some great sessions to come.